Hello everyone, I'm Najma Nazari from the University of California, Davis. I'm a member of ASIC Research Lab with the supervision of Dr. Human Homayoun. This course development curriculum is funded by Intel Corporation. In this talk, I will be giving you an overview of the Intel DevCloud. This is the first video in a series of training modules that would explain how to design the hardware accelerator with using DPC++ on Intel DevCloud. The first question is why DevCloud? If you want to run compute-intensive and time-consuming programs such as machine learning model for image classification, the training phase takes several hours on your system. Besides, for this compute-intensive, we need powerful CPU, also GPU. FPGA also can accelerate the model. Intel DevCloud is a cluster of Intel Xeon scalable processors connected to GPUs and FPGAs. As taking advantage of multiple types of architectures is a challenge for developers, and separate tools are required for each architecture, DevCloud is a key solution for that. Actually, DevCloud provides access to precompiled software optimized for Intel architecture. Intel provides a unified cross-architecture programming model called oneAPI that it reduces programming complexity and also minimizes the barriers to adopt new innovative hardware technology. If you want to use DevCloud, it provides you Linux-based login node, or you can connect to use it through the Jupyter Notebook. You can upload your code and data and then submit the jobs. When the job is done, the result would be in your home folder. The benefits are nothing stops you from running your model. Run the model within minutes through powerful CPU, GPU, or FPGA. And who can use DevCloud? Developers, data scientists, professors, students, startups, and others can request access for full access to the latest Intel CPUs, GPUs, and FPGAs, Intel oneAPI toolkit, and the new programming language, Data Parallel C++, DPC++. Good news, access is free for 120 days with the possibility of an extension. This slide shows the architecture of DevCloud. The cluster consists of multiple compute servers, consists of compute nodes, storage servers, and login node. Actually, there are two different ways to access the DevCloud. The first one is run a Jupyter Notebook session directly on one of the compute nodes. It should be mentioned there may be other people connecting to your compute node, and it reduces the available compute power. Therefore, you can reserve a full node for your job and even use multiple nodes at once by submitting a script to the job queue. The second way to access DevCloud is SSH. When you connect using SSH, you connect to login node, not compute node. On the login node, you can only develop and compile your code. If you want to run applicant, you have to submit it to the job queue to run it on compute node, as it has more computation power. After your registration, Intel will email you your credential. It has also a link to connect to your account on DevCloud. It will redirect you to the next slide. Okay, so click on the connect. Then you have two approaches to access DevCloud. Connect with a terminal, connect with a Jupyter Notebook. I choose connect with a Jupyter Notebook. After click on one-click login, the Jupyter Lab environment comes up. Afterwards, you can see the interface like below. There is a welcome.ipynb in your home folder. It is very helpful tutorial to get familiar with Jupyter Notebook in DevCloud. If you are not familiar with Jupyter Notebook, this slide provides the basic on how to use Jupyter Notebook. For example, how to run a shell and how to code as a Python or Bash script. Now, when you see cell like below, the line that begins with exclamation mark echo running, this is code that you can run. Second, if you mouse click on the cell, you will be able to edit the code. While you are in the cell, press Ctrl plus Enter to run the code in the cell. In the top right corner of the page, the indicator will change. This means that the kernel is busy. If the code begins with exclamation mark, it will run in the Bash shell. Otherwise, it is treated as a Python code. What is a job? Actually, anything that we want to run on compute node is a job. For submitting job to compute node, there is a job queue that you have to submit your job there. You can submit a job by JavaScript, which is only Bash. How to create a JavaScript? The first line of a script should contain the following code. This code changes the working directory to the directory where the script is located. The rest of the script can be a regular Bash script. It should be mentioned that you must have an empty line at the end of the file, otherwise the last command will not run. Note that only Bash JavaScript are supported. So if you need to run a Python application, you can add the corresponding Python launch line to your Bash JavaScript. For example, echo running my application.py, Python my application.py. The command to submit your JavaScript to queues is exclamation mark qsub, the name of JavaScript. As mentioned before, submitting a job can be done through a JavaScript file. For example, for Python application, the name my application.py, suppose that the application consists of, for example, import some Python module, load the data set, set up a neural network, and etc. For this purpose, submit Python application as a job to the queue. In the same folder, use your favorite text editor and create a file, my JavaScript. Or you can use %mark, write file, name of your file to create a new file in Jupyter cell, then add the following 2 lines. To check the status of your job, you can use exclamation mark qstat command, which R means running, E means error or a transition to a normal job, Q means queued. When the job is completed, it generates 2 output files, .o and .e file, that denotes the output and error respectively. Job name, .o, job ID. Job name means the script name or a custom name. Job ID, the number that got from the output of the qsub command. Using %cat command, you can see the content of these files. Exclamation mark qsub command has some parameters that the full list of parameters are in the link. For example, using -f parameter, you can send an argument to your job. Also, you can submit multiple jobs. Above command requests a wall clock time limit of 24 hours and passes a command line argument equal to 13.2 to the job. This slide shows some command to get information about the pool of servers. For example, how many compute servers are available, how many of them are free, what are the time limits for queued jobs, and etc. When you connect to Jupyter Notebook, there is a temp directory that you should not use it. Be aware that your home folder is shared between your login node and compute node. As you can see, each account has 200 gigabytes of storage. Exclamation mark get kodo command shows the storage that you use. Good news! You are free to write data up to this limit. Transferring data between local machine and DevCloud is easy. You can use upload button to upload your code and data to DevCloud. First, upload a zip file to the DevCloud, and then we unzip it with following command. Exclamation mark unzip the name of file.zip. Also, you can download any file to your local machine. For example, the output of your job, as shown in this slide. As mentioned before, the second way to connect to DevCloud is using SSH. The best way in Windows is use Cygwin. It provides Linux-based environment in Windows that is more simple compared to PuTTY. The way of installation is documented in the link. This slide shows how to install Cygwin. First, download the script by clicking on Install Cygwin in the automated installation and run the script. Then select More Info and then select Run Anyway button. A command prompt will appear. When asked for a proxy, just press Enter. Then select the address for installation or just press Enter for default location. Finally, click on a Start button to see the Cygwin icon and run it. So now installation of Cygwin is done. Then you will see the following directories in the installation location, and it is similar to Linux environments. So how to configure SSH? To launch Cygwin, you have access to a Linux-like environment. To finish the setup of connection to the Intel DevCloud, proceed to the article Connect from Linux Mac OS Cygwin SSH. The easiest method to set up SSH connection is by downloading and running an automated installer. This slide shows how to configure SSH by downloading the key and bash script which is provided by Intel to automatically install the key. After configuring SSH, you can connect to DevCloud using SSH DevCloud command. So, welcome to DevCloud. The rest of command is similar to what we presented on Jupyter Notebook. Thank you for watching. I encourage you to follow with other videos, and there will be also a GitHub repository that provides all the codes.